Have you ever thought of a for loop? Have you ever looked at a for loop and thought, is it efficient to use a for loop, or is it more efficient to use an array's for each method? There's this for each method on the array prototype in JavaScript, right? You're aware of that, right? So which one do you think is more fast? Especially this is very important when it comes to dealing with bigger list of items. Let's say you have a huge set of data points, data items in that huge array that was sent by the backend to your front-end application, and you're now stuck with going through those items and looping through them and finding something, doing something. So which one do you think is more appropriate? I used to think, for each, it's just the most normal thing that loops are the basics, the basic 101s that we need to learn, right? So why is it is it still a good option to use it? I used to think like that, and I used to think the for loop is the basic of a language, right? Your JavaScript's core language feature is this for loop. For each is just a function on an array prototype, so it's more confined to arrays. Whereas you can do for loop on any kind of iterable, you can only do for each on an array. So I used to think, which one is good? I used to always think array loops or for loops used to be. I used to think that for loops are the best, are the most efficient. But the thing you need to consider here, I mean, if you've not already guessed the answer, I think the answer might surprise you. The thing here you need to understand is how many assignments, how many reads, how many writes are happening during that activity of the for loop, right? If there are more things happening within the for loop block, within any block for that matter, right? The number of actions, the number of things that are happening in that looping construct really defines whether that block is more efficient compared to another block, right? So that's what we will look at in today's video, and then we'll see how this goes. So for this, what I've done is I've created a codepen setup, and this codepen setup is pretty simple. There's not much it's just bit of JavaScript, and then it's a bit of looping that is happening. I'll try to walk you through this one, and eventually we'll run this and see whether it works, which one's giving better results. First of all, this is some cleanup code to make my console cleaner, and then I took a really big array of items of you can see the length of these items is approximately 10 billion. Is it 10 million, right? It's not billions. This is thousands, this is millions, 10 million. So there are 10 million items in this record, in this array, and then each item is a 0. So if I comment everything out for now, and I simply log this thing, right? Simply logging this thing, really big array. What happens now is, let's wait for this, and there you go. You have those items. I'm not going to open it because it's 10 million, right? So everything is a 0. And if you consider, I'll remove the log statement for now. if you consider this structure, this is one of the ways you can use to create an empty array or a dummy array of some fixed number of items. If you don't know the length which you need to create, this is a very rare scenario. You would not be creating arrays like, you know, when you wish, right? Generally get the array from somewhere and then loop through that or do whatever you want to do with that. But you know, this is a way to do it. Like, you need to pass an iterable as the first argument and the transformer function as a second argument, where every item, every array's item is passed, and then, you know, whatever is returned will be the value there. So right now I'm returning 0. You can return null or undefined or whatever you want. The iterable's main prop or, you know, prop of that iterable object is the length. Length is the only mandatory parameter to be passed, so I'm passing whatever length required. And this array.from is an ES6 feature. It's not compatible with all the browsers. You have to check that. But here we are. So I'll let me uncomment one by one, right? So you have I'm using, by the way, performance API here. Performance API is part of the core web APIs. What this does is it allows us to mark the point at which to start the performance marking, and then the point at which to end it. You're just creating two marks here, the for each start and for each end, and then you do this line, both these lines, to make sure that, you know, you're creating a measure which has a name for each, and it's measuring between these two marks, right? And then you have you get that measure using this, and then you there could be multiple measures. So you get the 0th item and then take the duration, print it out, and that's what gives us whether, you know, it is you know, faster or slower. Okay, if I uncomment this one, right, I'll uncomment everything except the console logs, because that is the surprise, right? Let's see what's going on in these two, right? So this is one version and this is the other version. At the top you can see I'm taking a count variable, and then I'm looping through the really big array, and for each item I'm doing a simple computation, simple addition computation. Okay, right? So the idea here is that for these two constructs, for each construct and the for loop construct, I want to make sure there's not much going on, and it, you know, whatever is going on is matching, right? So here also you have a variable, and this variable is also incremented, and you have this performance mark start and end, and then you have the measure and the for loop. All right, sorry, that was my baby. All right, so these two are there, they're being benchmarked like this, and they're ready to check, you know, for you to see okay, which one do you think will be faster. Let's first of all uncomment the console log for the for each statement and save this, and you can see 127 milliseconds, right? This is all milliseconds, so that's relatively slow. You might think it's slow, right? Because it's just a loop, you know, it should happen faster. But let's comment this out and uncomment this one, the for loop, and suddenly you can see a lot of delay, and hopefully, yeah, you can see it's around 2100 milliseconds, close to more than two seconds, right? So you'll be thinking, okay, so these two are pretty much the same thing. Whatever is happening inside each of them is exactly the same thing. We're starting at count 0 and we're incrementing the count to 2 million. That is all we are doing. So what could be the difference? What could be the really, the reason behind the lag in the case of for loop? Let me uncomment both of them. You can see both of them now. The real reason is, like I said earlier, it's the computation part, right? So how many computations are happening in a particular loop? If you see, the for loop construct is not a single thing, right? It's not a single block of code. There are many chunks of code that are happening, right? You can see here, if you look at this is assignment. That is one computation, but that happens only once for the entire looping, right? So that's one construct. And there's this conditional that gets checked, right? So this conditional is also one computation. And there's this increment, right, which is one computation. There are essentially two computations that happen for as many times as the number of times you're looping through, right? So and count plus plus is one computation, so there are three computations happening for the for loop. And if you come back to the for each, there's no such computation, right? Array array internally takes care of giving each item, so there's no computation there, right? So that's what matters. That is the reason you have this lag, this enormous lag, because there are three computations, whereas where it should only have been a single computation. So that's the reason you see the difference. You can see it clearly. So if the take from here, the gist of this simple experiment is to make sure all right, I thought I stopped my recording, but to make sure that when you are in fact working with huge lists of items, you make sure that it's you use a more performant looping block or performant iteration block, and not fall for that issue again. So hopefully this should work. I think this is a really simple experiment. Let me know your thoughts, how you liked it or disliked this experiment. What do you think? Which one do you like? Is it the for each block or the for loop block? And yeah, I'll see you in the next one. Thanks for watching.